Hello everyone, welcome to this course on reinforced concrete design. I am Professor Arunasis Chakraborty from the Department of Civil Engineering, IIT Guwahati. Today we have assembled here to learn the fundamentals of reinforced concrete design. It is a subject that forms the backbone of modern structural engineering.
As you can see on your screen, the collage of different structures. The common element among them is the material used. You can also notice the growth of infrastructure sector in our country. Reinforced concrete plays the central role behind this growth. Therefore, this subject is so important, which ensures safety, serviceability, and economy. As you can see, reinforced concrete is a combination of two different materials that complement each other. Concrete, which is strong in compression, and steel reinforcement, which is strong in tension. When these materials work together, they create a structural system that is durable, versatile, and capable of resisting a wide range of loads. In this course, we'll learn how to design beams, slabs, columns, and foundations so that they are not only safe but also economical. We'll explore fundamental concepts like limit state design, shear and bending behavior, crack control, and serviceability requirements. More importantly, we'll understand why the structures behave the way they do, because good design is not just about following formulas, it is about understanding the mechanics behind them. Now let us go through the syllabus of this course. It is subdivided into three different modules. The first module will start with the basic concept of limit state method, followed by different structural components, for example, beam, slab, staircase, column, foundation, and the module will end with ductility detailing as per Indian codal provisions. In the second module, we'll focus on different spatial structural elements, for example, deep beam, flat slab, and different types of water tanks that very often we encounter. The last module will focus on FE modeling of structure using StatPro. So we'll start with 3D modeling, followed by model analysis, response spectrum analysis, and time history analysis. We'll use different books as you can see on your screen. We'll mostly follow the first three books. However, there are other books also that you can refer. In addition to these books, we'll also refer Indian standard codes. Some of them are enlisted here. I will update you as we go through this course about different codal provisions. Reinforced concrete design is a skill you will carry throughout your engineering career. Whether you go to construction, consulting, or research, the principles you learn here will guide your decisions in the real world, from designing buildings and bridges to ensuring public safety. So approach this subject with curiosity, ask questions, visualize the forces at play, and connect theory with practice. By the end of this course, you'll not only know how to design reinforced concrete elements, you'll be able to think like a structural engineer.
With that, let me conclude here. As we progress in this course, we'll have more interactions, and I suggest you go through the materials, solve the problems, raise your doubts, and hope that this course will be really useful for your future career. Thank you very much.